What? I can't hear you. What is?
Inaudible.
Kids shouldn't play with fire. Yeah.
Unfortunately.
So, let's start with a little bit of a demonstration. Why is fire awesome? Here's one reason. Wow. Yes. That's an example of how kids shouldn't play with fire. Let's do it one more time and I'll tell you what this is.
It didn't work.
I know.
It didn't work?
It worked because you. Oh,
One more time.
I can't see fire. No fire.
Maybe it's something different.
I don't want to do it.
You don't want to do it? I don't want to do it. How do we do this? If I put it here. Alright, ready? There we go. So, yeah, this is called lycopodium. It's a chemical substance. And back in the day when cars had just come around, they used lycopodium as a kind of fuel. But now, just magic shows. So, we talk about fire, and more specifically, how to make fire. How to make fire. Or, as I like to say, how to cook fire. You know, in some sense, you know how to cook fire? In some sense, this is going to be a little bit of a cooking show because we need to figure out what are the ingredients. You know how you cook food with different ingredients? What are the ingredients of a combustion reaction, which is the scientific name for fire? So take a look at this and tell me if you can guess what the ingredients might be. Take a look at this.
Helium. Hydrogen. Carbon. An element. Elementary school.
What are the ingredients? There are 3 to be specific. Also, what's inside my balloon, if in case you're wondering, is called hydrogen. Hydrogen is the most abundant substance in the entire universe, and it's very flammable, and it's lighter than air. That's why it flies. Again? One last time.
It's sort of heavy.
Whoa.
Again.
One last time. Ready? 1, ready, 2, 3, go. So, what are the ingredients of a combustion reaction? What are the ingredients of a combustion reaction? Does anybody know? The first ingredient is, I give you a clue, invisible. So you're cooking and there's nothing in the pot, but there's something in the pot. What is it?
Tell me later.
Air is close.
Tell me now.
Oxygen! Oxygen! Look at this. Look at this. So, if I make a combustion reaction here, do you see it? Yeah? And if you don't see it? Here. And if I take oxygen away from it, it is gone. So you definitely need oxygen to make fire.
Wow. That's a yo-yo.
That's a yo-yo. Is yo-yo necessary to make fire? But the thing is, if you don't have something to burn, you will not be able to make fire.
Don't be silly.
If you don't have something to burn, and what do we call stuff that we burn for a specific purpose? Fuel!
A healer.
Right, fuel, correct. So I have fuel in there. It's also hydrogen. It's a gas form of fuel. Fuel can come in solid and liquid as well. I have oxygen in the room and still no fire. What's the last ingredient of a combustion reaction? What is it? Yes. We already said fuel. What? We already said fuel. What?
Fuel, oxygen.
Heat.
Oh.
If you want to make fire, you need to combine fuel and oxygen. How do you do it? You raise the temperature.
Okay.
You need a source of heat. I'm going to leave that here. I put my ear protection on. When you mix heat, fuel, and oxygen together in a pressurized zone, that is a room with no way out, that is that balloon, you will get an explosion. When I count to 3, definitely plug your ears. It's going to be like 1, 2, wait. Still there? 1, 2, 3.
Do it again. All right.
Don't do it again.
No. So, heat, fuel, oxygen makes fire. Someone wondered, though, what will happen if I just throw a different bunch of stuff inside my fire? For example, what will happen if I throw some alcohol on fire? Will it burn? Will it not burn? It will burn. It's very flammable. Alcohol is very flammable. And then someone else was like, hey, let's try another chemical substance like potassium. How will potassium burn?
What color is it?
Potassium, right?
Purple.
Potassium. And then someone else was like, how about lithium? Let's throw some lithium in fire. See what happens. And then someone else was like, how about copper? Copper.
Green.
You know something very common that is made of copper?
Pennies.
No? Pennies, right. And there's something else also made of copper. Very famous celebrity.
Wires.
It's like this.
Wires.
The
Wires.
Statue of Liberty. Why is pennies brown and Statue of Liberty green? And both made of copper.
Oxidation.
Oxidization. And that's the exact reason why when you burn copper, you see
A transcript. What are you transcripting?
If you remember, we
Let me
said
see your
combustion
transcript.
reaction is when you mix fuel and oxygen by raising their temperature. In other words, we are oxidizing our water. And you know that person who thought about throwing a different bunch of stuff inside fire also realized that that's probably how fireworks work.
Purple.
What?
A green.
Spell purple. P-A-C-E.
Okay. How about this? Alright, okay.
So cool.
Now. Oh no. So, if I could just write over here, what am I feeling? Heat. Heat. All right. So you know what happens when you heat up the air?
It goes up.
Let's heat it up. Let's see what happens.
Recall.
So the air inside this balloon, what will happen if I heat it up?
It will go up.
It expands. It expands. And as the air expands, it gets lighter. You know how it works? As it expands, it gets lighter, like a feather. Have you seen feathers move around? That's what happens to air as it heats up. It gets lighter and it goes up. Hot air rises and cold air. Cold air.
I don't know what happened.
You don't know what happens? I just told you. As you heat up the air gets lighter and it goes up. And as
The air gets colder.
it gets colder, the molecules go back to their original position. And they get just as heavy. Come down. Whoa, whoa, whoa. Oh no. It's okay. It's alright. I'm sorry. It's not my fault. It's not my fault. Okay. Alright. Let's move on. So someone looked at the hot air balloon and understood, yes, when you heat up the air, it expands. Alright. What will happen now if I heat up the air inside this bottle? You'll make a rocket. Yes. I know, it sounds crazy, but that's how it works. When you heat up the air inside this bottle, the air will be so big, so expanded, it cannot be contained in this bottle. So big, it'll have to run away, it'll have to run out, press out. This exertion of energy, everyone, will take us to the, do you know where?
No.
Moon. All right, let's expand the air. Here's some fuel. Here's some oxygen. And I have a heat source here. It's a spark. You know, sparks are hot. Okay. Let's see if we can go to the moon.
We're not in it. We're not in it.
You're not where?
We're not in it.
You're not in there?
No.
Get in.
No, we're too big.
So we're going to count to 3. There's going to be a liftoff. We're going to arrive at the surface of the moon. 1, 2, and 3. Liftoff! Welcome, everyone, to the moon. That's the end of our show.
Cheers! Cheers!